Good morning, and welcome to the final lesson for Gen 311. Today I will be introducing the topic of phylogenetic trees. I actually think this slide deck theme is an ironically good representation of this topic, but you'll know more about why later. To simply start with some vocab, I'll use this tree as an example. There is a smart reason that phylogeny can be represented in a shape reminiscent of a tree. As it is rooted in the ground, we can call it a rooted tree, and this node carries or connects everything above it. Anagenesis is like the trunk reaching up to a single branch without deviation, whereas cladogenesis is like the trunk branching out literally into two or more. To describe this relationship between two branches, a term called OTUs, or Operational Taxonomic Unit, categorizes the similarity between the groups being studied. For instance, the branches on the left side may be compared to the branches on the right side. These are OTUs that can be analyzed and differentiated. Within a larger subset of branch, you may find twigs, and connecting the two are called internal nodes. They are like the branch within a branch, or how a clade is within another clade. The most recent common ancestor is like the connector of the tree. It describes what relates all the branches. In this image, simply the trunk could be the most recent common ancestor, but if we were just to look at the left side, this larger branch may be the most recent common ancestor of these smaller ones. To be fair, the outgroup is kind of hard to explain using this example because this tree is truly a single entity, but an outgroup, as you will see, is like one branch that all the rest can be compared to. For instance, we may compare the characteristics of this branch to all the other branches on this tree. Okay, and now for a little exploration of phylogeny through my ever-growing stock collection. We will be using the terms that I just discussed, so please scroll back in the video if need be, but just as a reminder, I've included the list on the side here. A few observations off the bat. If you were to rotate this image to the left, you would see it looks kind of like our rooted tree. And notice the pink pair of socks in the upper right, which for the purposes of our observation are our outgroup. In other words, all other socks are being compared to this one as it has a direct connection to a most recent common ancestor of all other socks being displayed. However, it also implies that it is the least related to the rest of the socks as they are to each other. Anagenesis would be like if you went straight down the line of descent without making all these other types of socks. Just imagine only one type of sock existed. That would make my collection fairly moot. On the other hand, cladogenesis explains how we have multiple variations of sock that are all slightly related to a common ancestor. OTUs then may allude to how related different socks are to each other. For example, the distance between the athletic footy socks is much closer than the ankle socks. On the right, you can see that I've grouped some of the socks, and these are called clades. And attaching this grouping of ankle socks to the knee socks are these internal nodes. Internal nodes can also be a recent common ancestor, so the most recent common ancestor of the dark striped footy socks is represented by this node, and the most recent common ancestor of all striped footy socks is this node.